So this is a quick demonstration of how to do fraud detection using the Elastic Stack. So we're going to have a look at the various different components that are involved in monitoring fraud and responding to incidents of fraud. And I'm going to kick off by having a look at what's typically involved in one of these stacks. So on the left-hand side, what we normally have is some data source, which might have several document types perhaps, all of which have to be ingested. And typically what we're doing here is cleansing and enriching, normalizing the data ready for analysis. And the next phase of processing is really to try and understand these documents and who and what they're exactly talking about. So if we see two different documents talking about the same person, then typically what we want to try and do is link them to that person and say, well, this is another repetition of a particular John Smith. So that's quite an advanced topic that we'll cover perhaps in other discussions. So we won't dwell too much on what's involved in that for the moment. And the other thing we tend to be doing there is trying to filter out the noisy entities, the things that connect everybody together. So there's certain businesses or bank accounts or telephone numbers or email addresses that tend to link everybody together, because you'll often find these in data that there's something that invariably links everybody together. And once you've pruned those out of the graph or the set of connections that are in your data, you can then start to do risk scoring. Because what we're doing then is we're looking at each individual perhaps and examining the meaningful connections in the data and who they are dealing with. And we're looking for anomalies really in the way that these people are behaving, which might indicate that there's fraud involved. And for each of these anomalies, we can actually typically provide some level of risk as a score. And generally what happens is that these scores are then output into a task list, which is a sort of a to-do list for investigators to go off and then explore a little bit more about what's behind the risks that have been flagged up. And the investigators, as I said, they typically use some kind of task list to work their way through the outputs of the risk scoring. And for those things that are actually genuine risks, they might choose to create a case and store away some details around their investigation. And they will typically use graph visualization tools to understand the little ecosystem around the risky entities and who they're dealing with and who else might be involved. So they might want to use some graph exploration tools to do that. And typically there's a sort of a feedback loop out of the investigations which help to tune the risk scoring algorithms. So they always, the risk scoring algorithms always have to walk this line between having too many false positives and too many false negatives. If they're over eager, then they flood the investigation team with false positives, so things that aren't actually risky. And if they're too conservative, then they fail to spot the things that actually could be a risk to your business. So there's a feedback loop that's often useful in terms of the results of investigations and the risk scoring algorithms and just how aggressive they are. So what we'll focus in on for the purposes of this demo is sort of the latter phases of this pipeline. We're going to have a look at an example of a risk scoring algorithm that's using the Graph API, which is part of the Elastic Stack. It's the XPack addition to the core Elastic Stack of Kibana, Logstash, Elasticsearch, and Beats. And we're going to make some calls to examine some data. And we're going to output a bunch of entries into a task list. And then we're going to see how investigators can respond to entries in that task list and work their way through investigations. So the data that we're going to examine today is real data that's been anonymized, but it's from an online marketplace. And what we're going to try and do is to tackle incidents of what we would think of as being review fraud. So this might be sellers who are trying to game their reputation in the online marketplace. So the common term for these things are sock puppets. So what we're finding is that there are 580,000 reviews in this, so that you're just over 500,000 reviews from 400,000 different buyers. So that's a lot of different people giving feedback. And the fields are basically the seller they're giving the feedback to, who they are, the buyer ID, the rating, so 1 to 5 stars, and the date and time of when they actually gave that feedback. And the sock puppets are kind of hiding in amongst all the buyers. The sock puppets are essentially fake buyers who are actually giving 5-star reviews to a seller in order to inflate their reputation. And we're going to try and discover the sock puppets in this data. So there's only a handful of them in this data set. And we're going to look at the tools and techniques that we use to actually discover these things. So let's actually have a look and flip over to Kibana, where I've got these 580,000 reviews preloaded. So there's just 578,000 reviews here. And we can see that each one of them consists of a reviewer, or the buyer, if you like, the seller that we're giving the feedback to, the star rating. So this guy's not thinking very much of seller 13 here. He's giving them a 1-star rating, and the date and time that this review was added. And we can use the graph user interface to actually start to begin to look at the networks that might occur in the relationships between sellers and buyers. And we can start to plot some of that out. So if we go into the graph plugin, which is part of the XPack extension, first of all, we need to pick the reviews index. And then we need to pick the fields that we're going to use to actually draw on our graph diagram. So if we click the plus button here, we'll start by adding the seller. And we can give the seller a particular icon and color. So let's give him something that vaguely looks like a business. That's a seller icon here. And let's go back and then add in the reviewers or the buyers. So that the reviewer is supposedly a person. And the last field that I'm going to add in is a date and time stamp. So it's the year, the month, the day, and the hour. We'll see why that becomes important in a minute. So hour is a fairly abstract concept, so let's just give it something vaguely abstract here. And that's our configuration set up. So if I shift click, I can just temporarily disable these fields, and I want to focus in on and find seller 1 there's about 240 odd sellers in this data set. So here's our seller. And what we can now do is if I disable that and focus in on the buyers, I can actually hit the plus button here and find all of the buyers that have been connected or strongly connected to this seller. So we find that there's a chap here, buyer number 17602, and he's pretty loyal. He's made 15 purchases in the marketplace, and all 15 of them have been from seller 1. So that's not necessarily indicative of a sock puppet, but it's just a strong relationship, certainly. And over here, we've got another buyer who's actually made 3 different purchases. And that's the extent of all the buyers that we're seeing currently. And this is because we have a setting here, which is looking for the strong relationship. So we're looking for at least 3 documents that determine that there's been an association here. So we'll just back that off to, we only need 1 document for the purposes of being pulled into the data here. So if we hit the plus button now, we'll start to see some of these kind of weaker connections, these one-off buyers in the marketplace. So here's a person who's only made 1 review ever, and it happens to be for seller number 1. So we started with our seller. We've got a bunch of buyers. If I take the seller away, we have this selection of people who happen to have bought from this seller 1. We might want to have a look at the coincidences of time when they actually were making these reviews. So if we hit the plus button now, we're going to add in the time-based elements to this. What we start to see is that there are a number of dates and times that these people have been doing their activities, and keep adding them in. So we can see here, for example, that this buyer has been active on all these dates at all these hours. And these aren't shared with anybody else in this little community here. But we can see that there are perhaps other examples where there are coincidences like this over here, where this buyer made a review at this time, and this happened to coincide with this buyer here. Now that again, it isn't necessarily indicative of fraud. You can think of this a little bit like car crashes. It's not unusual for 2 people to collide with each other. But what would be unusual is if the same two people had more than one collision and actually kept colliding into each other multiple times. That would be a little bit strange. So what we want to really look for in the data is examples of two different people having multiple instances of a collision, if you like. So synchronized behavior. They keep seeming to come back and make their reviews at exactly the same time. And that's the sort of pattern that we want to look for in the data. And it would actually be very tedious to do this manually using the GUI. So actually what we want to do is make use of the API. So behind the scenes, the graph user interface, if you click on the settings and then the last request, you can actually see the sorts of requests that it's making of the back end when it tries to explore the graph, and you can see the results that come back. We can actually make calls directly from a script to do these explorations and also to look for the shapes that we're interested in finding in the data. So let's have a look at an example script that does exactly this. So this, if you like, is our scoring script that we're about to look at. We're going to look at a tool which is going to output tasks or alerts for investigators, and we'll see how that's made up. So this is my script. It's about 2 sides of A4 here. If you were to print this out, the first part of the script here is just setting up an alerts index. So this is what it's going to actually output. It's going to create a number of alerts describing the sort of risk that's involved, and it will give a URL that somebody can click on to actually go and investigate that risk. And we kick things off by getting a list of all the sellers in the marketplace. So that's what this function here is doing. It's just a regular Elasticsearch search. It's using an aggregation to say, get me the top sellers, and I want to go and explore how their buyers are behaving in the marketplace. So first of all, we get just this flat list of sellers. And then essentially the main part of this script is this big for loop here where we examine each seller in turn. For each seller, we're going to repeat exactly what I just did in the user interface pretty much. We're going to run a query to find the seller, and we're going to then discover their most loyal reviewers. So when I backed that certainty down from 3 to 1, that's what we're seeing here, whereas we're saying we're looking for reviewers who might have only actually bought from us once. And we'll get about 50 of those back. And that's going to be our sort of first tier of graph exploration. And then what we're going to do is we're going to go beyond each one of these reviewers and say for each of these reviewers, let's now pull back the date plus hour of when they made their reviews. And rather than getting all their reviews for any seller, we're actually using a guiding query here to stay on topic, if you like. So what we're doing is we're saying, yes, find these reviewers who've bought from this seller, and then find at what times of day and on which dates they made their reviews, but for this same seller. So we're looking for the feedback that pertains to the original seller that we're querying for. So that will give us our visualization like this. It will give us a healthy selection of the buyers and their activities. And then we're going to start looking at the shapes in the data. So we can see a shape here, for example. Here's a buyer. He's been buying lots of things at different times of the day, but there's no kind of indication of fraud here because there's no interactions with any other people. And remember, what we're looking for is actually multiple equivalents of these blue dots between pairs of buyers who should really be operating independently. So each one of these different little islands here is what's called a subgraph. And we've got a library in Python called NetworkX. Or sorry, I say we. There is a library in Python called NetworkX, which is useful for doing these forms of graph analysis. So our first task really is to create an instance of a in-memory graph structure using NetworkX. And then we're going to load the results of our Elasticsearch graph exploration query into this graph. So in Elasticsearch, we talk about vertices and connections. In NetworkX, we talk about nodes and edges. So we just load the data in using these two loops here to load the connections and the vertices. Once we've got them loaded into NetworkX in memory, we can then start to break it down into these islands that I was talking about. So there's a function called get the connected component subgraphs, which is just a fancy way of saying get each one of these different islands that we're seeing in the data. And then for each one of these islands, we're going to run around and examine just how many hour nodes there are in that little subgraph and how many buyers or reviewers there are in that subgraph. And we're really only interested in subgraphs where the number of hours is greater than 1 and the number of reviewers is greater than 1. So, for example, we would eliminate this subgraph because there's only one reviewer in that. He's not actually synchronizing his behavior with anybody else because it's just a bunch of hours that are connected to the one reviewer. If we find an island with more than one reviewer and more than 1 hour, then we actually want to examine the interaction between these things. So for each reviewer, we're going to ask NetworkX to discover all of the possible routes that connect that reviewer 1 with that reviewer 2. And we're going to use what's called a cutoff here, or a depth 2. So what that means is we're going to go from the reviewer to a date time to another reviewer. And that constitutes one path. And we're going to count how many of these paths we have. So if you like, it's a bit like how many times did this driver crash into this driver. And if it happens once, that's not necessarily a coincidence or surprising. But if it happens more than once, then that is something that we call a coincidence. So we take the number of paths that connect these two reviewers together. And if there's more than one, then that's a risk indicator. So it's an example of synchronized behavior, and we add 1 to the number of coincidences. If a seller has more than one coincidence, or sorry, any coincidence, then we're going to create an alert. And the severity of the alert is based on how many coincidences there are. And the alert gets stored as a document inside Elasticsearch in my alerts index. So that sounds like a lot of work on 500,000 reviews, but it's actually quite quick to run. So if I flip around to this command prompt here, we can run this Python script we just saw. It's examining all these reviewers, 500,000 reviews, and we've actually identified 2 sellers that look interesting. So let's have a look at the actual documents in Kibana now and see what's happened. So the first thing we have to do is, as a one-off step, is to tell Kibana about this new index that we've just loaded. So we'll say there's an index pattern called alerts. I'll try and spell it correctly. And it consists of a seller, a risk rating, and a risk type. But crucially, there's one field here called URL, which is something that enables an investigator to actually drill down into the details. So that just needs a little bit of configuration. We just need to go in, and for that URL field, we need to tell Kibana that it is a URL. Rather than showing the full URL, which is a bit gory in detail, we're just going to have a little label that says show risk. And that's Kibana configured. So now what we can do is let's go into the Discover tab. We're going to create our task list now. So this is what the investigators are going to use to respond to these risks that the scripts are highlighting. So if we pick the alerts field, let's just tidy up the default display here. So let's have risk rating as our first field. Let's have the risk type. Let's have the seller. And of course, let's have the URL that enables us to drill down. So that's the show risk function here. And ideally, if we're dealing with a task list, we want to have this sorted by default by risk rating descending. And I'll probably save this away now because this would be a useful configuration. So by task list. And this is what investigators would go and have a look at every single day, is they work their way through this task list of things that have been flagged for investigation. Now, what the URL that was created by the risk scores does is it loads a blank graph workspace. There's one more piece of setup that we need to do, which is to save our graph workspace. So I didn't save it a minute ago, so let's just run through the exercise of configuring that again. So we said we had reviewers who were people. We said we had sellers who were businesses. And we had the hour icon, which was something abstract like that. And that's our configuration. And we had the setting set to 1. So I need to save this as a saved workspace so that these URLs will work. So I need to call this reviews, and that's my saved workspace called reviews. So these URLs that we have in my task list will now actually take that workspace and it will plug in the seller ID and run the graph query that led to this risk. So everything that was in the Python script here to do with gathering together the evidence that was risk assessed, this whole query here is essentially passed in this URL. So when we click on it, we're seeing what the algorithm saw. So one of the things you can pass in the URL is $query as a parameter, which fills in the search bar. So the search can take free text searches, or it can actually take graph queries. So if we look at the last request that was sent, this is what was in that output from the script. So it's all the details that are required to gather together this picture, which is what the algorithm saw with all these various different islands, and one of them which had a very high number of coincidences between the various different entities in that island. And as an investigator, you then might start to tease apart just what the risk was in here and whether it really genuinely was a risk to your business or not. So there's just one extra little bit of configuration that I'll do to my investigator's workbench. If we go into visualizations, we can set up a visualization, for example, of reviews over time. So let's set that up now. We're going to pick reviews and we're going to have a daily based visualization. These are all reviews. So here's star look. I'm looking at all reviews. And if I copy that URL, and I go back to my graph, if I go into the settings here, I can configure a drill down URL. So let's paste in the URL for that time-based visualization. And it says, this looks like a Kibana URL. Do you want me to change it into a template? So it's going to remove the star bit of the query that we had, which was look at all the reviews. And it's going to change it and insert this gquery template marker here. So what that means is it's going to take the selections that I have in my workspace, so the selected reviewers that I might pick in my workspace, and it's going to plug that into the query and open that URL. So I've given it an icon here. So that now means I have the ability to select these reviewers, for example, and show their activity over time. So we're going to, again, open up a URL. We're going to supply a query that gets passed into the URL bar here. And then we're showing the activity of these reviewers over time. And I could actually go in and make this a little bit more detailed and say, we'll actually break down each one of these bars by the reviewer. And here's where we'll start to see some of the synchronicity to their behavior. So we can see that exactly the same hour on exactly the same day, the same set of reviewers are coming back to give 5-star ratings to that one seller. So this does indeed look like a fraudulent system. So let me just save that workspace away again, because I've now got this sort of drill down URL. So there's my reviews workspace. And it now means that if I go into any other risk in my task list, when I open it up, I'm seeing the risk that was associated with that particular seller, and I've got the ability to select various different reviewers of interest and then use that drill down again and show how they are active over time. So it's a different profile of activity here. So this particular one we might say is benign, for example. So I could actually save this away with the actual nodes. I could save it away with a note saying seller 58 or whatever it is, benign, I'll spell benign reviews. So that's some notes that you might want to choose and attach to your investigation. So this is how you might actually begin to collaborate with other investigators on a particular case. So hopefully that gives a good example of how you can use the various different components in the stack to assemble this pipeline of investigation and scoring using the Graph API from your Python script in this case, or it could be any other language, to gather together information and then output a bunch of tasks for investigators to then explore using the Graph UI.